So good afternoon, everyone. Welcome to the national webinar organized by Auxilium College. I request Ms. Teresa Roshini, the MC of the day, to start the session.
A very good afternoon to everyone present here. We extend a warm and cordial welcome to the Board of Management, resource person, staff and students for the national webinar on application of mathematics. Every morning is a surprise and every sunrise is a challenge and each day is a gift. To give the first fruit of the day to the Lord is one of the most valuable ways to show our love to God. Prayer is not asking. Prayer is putting oneself in the hands of God. Let us invoke God's blessing through prayer song.
As we gather in this place today, Holy Spirit, come and have your way. Have your way. As we lay aside our own desire, sweep across our hearts with holy fire. Oh, have your way. This is your house, your home. We welcome you, Lord, we welcome. This is your house, your home. We welcome you today. As we offer up our hearts and lives, let them be a living sacrifice. Oh, have your way. Be glorified in everything we do. Be glorified in everything we say. Oh, have your way. This is your house, your home. We welcome you, Lord, we welcome. This is your house, your home. We welcome you today. We welcome you today. Yes, we do. We welcome you today.
I invite Dr. L. Sujata, Head PG and Research Department of Mathematics, to welcome the gathering.
Good afternoon. It gives me great pleasure to welcome you all for the national webinar on applications of mathematics organized by the PG and Research Department of Mathematics, Auxilium College, to commemorate 133rd birth anniversary of the great Indian mathematician Srinivasa Ramanujan. A special welcome to the resource persons of the day, Dr. Madhumangal Pal, Professor, Department of Applied Mathematics, Vidyasagar University, West Bengal, and Dr. Ravishankar, Assistant Professor, Senior Grade, School of Advanced Sciences, VIT University Vellore. We are very happy to have you amidst us, sir, on this special occasion. I wish to extend my warm welcome to Reverend Sister Alice Katie, Secretary, Dr. Sister Jayashanti, Principal, Dr. Sister Amala Valarmadi, and Sister Sumadi, Vice Principals, Shift 2 and Shift 1. My heartiest welcome to Mr. DINESH, Catalyst, Executive Director, Audacious Dreams. Thank you, sir, for providing us the technical support. I welcome all the faculty members, research scholars, and students from different parts of India. Thank you for showing your interest to participate in this program. Last but not the least, I welcome our co-organizers, executive members, and students, without whom this event will be incomplete. Once again, I welcome you all for this platform of sharing the knowledge. Happy National Mathematics Day to all. Thank you.
Thank you, ma'am. I now invite Dr. Priyanka Victor, Assistant Professor, PG and Research, Department of Mathematics, to introduce our resource person of the first session, Dr. Madhumangal Pal.
Good afternoon, one and all. On this special day, commemorating the birth of Srinivasa Ramanujan, the man who knew infinity, it brings me immense pleasure to welcome you all to this webinar on applications of mathematics. Srinivasa Ramanujan is remembered for his exceptional contribution in the field of mathematics. The main objective behind the celebration is to raise awareness among the people about the importance of mathematics in the development of humanity. On this auspicious day, I am happy to welcome and introduce a person who has a great passion for mathematics, Professor Madhumangal Pal, Professor of Applied Mathematics, Vidyasagar University. Professor Madhumangal Pal has received gold and silver medals from Vidyasagar University in MSc and BSc Mathematics respectively. Also, he received Computer Division Medal from Institute of Engineers in 1996 for best research work. In 2013, he received Bharat Jyoti Award for significant contribution in academic field. Professor Madhumangal Pal has successfully guided 34 research scholars for PhD degrees and has published more than 320 articles in international and national journals. His specializations include algorithmic and fuzzy graph theory, fuzzy matrices, genetic algorithms, and parallel algorithms. Professor Madhumangal Pal is author of 8 textbooks published from India and United Kingdom. He has published 21 book chapters in several edited books. Professor Madhumangal Pal completed 3 research projects funded by UGC and DST, and 1 project is going on. He is also a member of American Mathematical Society USA, Calcutta Mathematical Society, and Advanced Discrete Mathematics and Applications. Recently, he is included in the list of top 2% scientists among all disciplines published by Stanford University. He is a member of several administrative and academic bodies in Vidyasagar University and other institutions. Sir, it is an honor to have you among us. I welcome you to the first session of the national webinar on applications of mathematics to motivate and enthuse the students to have a positive attitude towards learning mathematics. Welcome, sir. The platform is yours. We are eagerly waiting for your talk on the topic numbers and coding. Participants, if you have any queries, please post it in the chat box.
Okay, thank you. Good afternoon to all of you, and thanks for your nice introduction. So first of all, I'd like to thanks to all the faculty members of the mathematics department and also the college authority for inviting me in this occasion. So actually, I have visited your college a long time, a few years back. Dr. Sujata, your head, PG and Research department, she was invited me, and she also visited our university a few years back in a conference she attended. So today, the National Mathematics Day. It is celebrating in the eve of our great mathematician, our Indian mathematician, a genius, on the 133rd birth anniversary of Srinivasa Ramanujan. So last year, no, not last year, this year, January, I visited Kumbhakarnan, your nearest place, or the birthplace of Ramanujan. And I saw a lot of things, a lot of works, his house, the museum maintained by the Shastra University. They are keeping a lot of informations. Okay. So, the Ramanujan worked on your number theory, your continuous fraction, your mathematical analysis, like that. In different areas, he have gives a lot of contribution. He has a lot of contribution. So number theory, the number theory is a very important subject in our, or we can say the foundation of mathematics. And it is widely used in your cryptography coding system like that to protect our ATM pin or the password like that. So numbers or number theory, basically, it's a very interesting subject. And Ramanujan worked long time back. This is a 133rd birthday. So he has invented all the works before, say 100 years old. His work is almost 100 years old. Even then, his work is now important in today's concept or to development of the today's societies. So his work on number theory is now widely used for the security purpose or to develop the cryptography. Okay. So just in this lecture, I just introduce you the very basic concept of the coding theory or cryptography. My lecture is mainly basically for the students, undergraduate or postgraduate student or research scholar, or we can say that it is an introductory lecture. So if anybody are interested to work with the cryptography, then he or she can enjoy my lecture. And this is not for the advanced researcher. Okay. Now I am starting my lecture. So this is the first screen, numbers and coding, or we can say the introduction to the coding theory. Now my first question is, I'm starting my presentation with a question. So I would like to send a confidential letter to my friends or my boss through a messenger. Messenger means who are carrying the letter or some messages. So I am sending one confidential letter to my messenger. Messenger may be my student or my colleague or my another third person, or I can send the letter through by post or through email. But there is a small chances to disclose the message, confidential message for disclosure. That means my friend or the students can open the letter and he or she can read the what matter is written in the letter. Now the question is how we can send. So how we can send the letter, confidential things to other person. So this is the big challenges. It is a long time, long standing problem, and it is solved by so many different ways by our defense people. Defense peoples are using this concept, the coding concept. Even then those are underground underworld people, they are also using the coding system. Lot of people are using the coding concept or the cryptographic concept in different purposes. Now, what is the way? The question is, what is the way to transfer a message from one place to another place without disclosing? That means the messenger can open the letter, but he did not understand what is written in the letter. Okay, so this is the main theme or main idea of the coding system. Suppose we have a message, say coffee house. I would like to say this is a code for any other thing, coffee house. So the following code may be used, or we can say we can convert the coffee house into a digital codes for the receiver. Okay, so this is a code of the coffee house. How we coded this text into digits? I have replaced A, capital A by 01, B by 02, C by 03, and so on. Small a by 31, more small b by 32, and so on. This is a way to code the string or message, original message in terms of some digits. This is another code. So I think nobody at this moment, nobody can understand what is written in this code. But I have followed a rule. So using the ASCII code of the alphabets which are used in the keyboards, the ASCII code for A is 65, B for 66, and so on. And small a is 97, small b is 98, and so on. And for the blank space, the code is 32. So using this ASCII code, I have converted the coffee house into the string of numbers. Okay. So see that first is C's. Code for C is 67067, and small o, the code for small o is 111, and 102 is the code for if, and so on. Okay, so using this concept, using this coding pattern, I have coded the word or the phrase coffee house into two different ways. So anybody or any person can coded this sequence of number into different forms. Okay, different technique may be used in to code the system. And how we can decode the system? If we send to the receiver the process or the formula for encoding or for decoding, then he or she can encode the coded information. Okay. Now I am, so first two example basically is taken from my own concept, but I am talking about some systematic rules or systematic methods for coding. A systematic method is shift cheaper, known as shift cheaper, introduced by Julius Caesar a long time back. So what is the concept of this your coding? So I am explaining the this method shift cheaper by an example. So if we shift by 3, that means in this technique, shift cheaper means we shift the letter to some other letters. So for explanation purpose, I consider here shift by 3. That means I'll shift all the alphabets by 3 spaces like that. According to these rules, shift by 3 means A is shifted to D. That means A, then B, C, D. B, C, D are 3 shifts. B is converted to E. That means C, D, E. C is converted to F. That means C, then E, C, D, E, F. So this is called the shift by 3 rules. Okay, that means a string is given, and we have we will convert the given string of alphabets by using this technique. That means we replace A by D, B by E, C by F, and so on. So according to this principle, what will be the coded string? X, A, B, Z, C. Suppose you have this message, you have to encode or the coded, what will be the coded? So for this input sequence, we replace X by A. X is shifted 3 alphabets, then X, the next alphabet of X is Y, then Z, then there is no alphabet, then we come back to the alphabet A. Okay, after Z, the next alphabet of Z is taken as A. So X is shifted to A is shifted to D after 3 shift, B is shifted to E, Z is shifted to C, Z, then A, then B, then C, and C is shifted to F. So what is the converted code or encoding message is this one, A, D, E, C, F. Okay. So original message is this one, X, A, B, Z, C, and encoded message is this one, say A, D, E, C, E. So this is the method. This is one method called the shift cheaper, and this method is used long time back to encode a message. Okay. Because this technique has some disadvantage. I am saying after in the next slide what are the drawback of this technique. So what will be the decoded message? For the coded message, this is the coded message. Okay, and one original message is given. That message is converted to this form PRJQT. This is the coded message, and how it can return back to the original message. So that process to return back to the original process is called the decoded message. Initial message to converted message is called the encoded message, and decoded message means the original message. That means it is returned back to the original message. Okay. So what is the code for original code for P? Original code for P is M, then N, O, and P. 3 shift is used, shifted to 3. So the 3 alphabet, 3 means we have to shift left here. And during the coding, we have shift right, but during encoding, we have to shift left. Okay. So P is decoded as M, R is decoded as O, Z is decoded as W, Q is N, T is P. Okay. So the encoded mesh is MOWNQ. For the coded mesh is this one. Okay. So this is the encoded coded meshes, and this is the original meshes or the decoded meshes. So the using the reverse technique, we can retrieve the decoded or the original meshes. So this is the just observation method, non-mathematical way to coding and decoding process. Okay. But for mathematical people or mathematics students, we can go for the mathematical modeling or mathematical formula or mathematical functions like that. So before going to the mathematical treatment, just I'm discussing what are the drawback of these techniques. This method is simple, but it has some drawback. What are the drawbacks? There are only 26 shifts. Only 26 shifts are possible. So anybody can decode the meshes with each of the 26 possible shifts. Okay. Using only 26 possible shift, anybody can retrieve the original meshes, or decryption is possible. Okay. A letter in this process, a letter or an alphabet is encoded to the same letter every time. That means if an alphabet O is present in 3 places, then the code for O are same in 3 different places. Okay. So this type of chipper is easily cracked by the hacker. So for this reason, this type of coding technique is not applicable nowadays. Okay, so a lot of better algorithms are available. So I am presenting another mathematical formula to coding the string. Okay. So first of all, I have converted all the alphabets in English dictionary. All the alphabets are converted to integers number. Okay, 0, 1, 0, 2 up to 26 for the alphabets A, B, C, D up to Z. That means all the alphabets are marked as 1, 2, 3, 4 up to 26 for the mathematical treatment. Now the shift by 3, this phrase or this technique is mathematically represented by this one, x plus 3 mod 26. Why mod 26? Because there are 26 alphabets. Here for explanation, I have considered only the uppercase alphabet. Now I have considered the lowercase alphabet, digits, or all or any other symbol, special symbol, but we can use any other special symbol, alphabets, digits, lowercase, uppercase, both for giving the password like that. But for simplicity of the presentation or for explanation, we consider only here the uppercase alphabets, and all the uppercase alphabets are marked as 0, 1, 0, 2 up to 26. And the shift by 3, this technique is mathematically written in this form. The encrypted function, this is represented in terms of function, expectation ex equal to x plus 3, where x is the code for any alphabet under modulo 26. Okay, that means the A whose code is 0, 1, A is converted to 4. 4 means D. That means A is converted to D. The code for B is 2. That means 2 plus 3 means 5. That means B is converted to E, like that. Now, what is the decrypted formula or encoded formula for this encryption function or encoded function? Just inverse function we can use to decrypted or decoded the text. Okay. So if you use ex by y, then what is the value of x? X equal to y minus 3. And x means dy, decrypted value of y equal to y minus 3. Just inverse function we have learned in algebra, no? When we have studied the function, and we already learned what is the inverse function, additive inverse. This is basically additive inverse. So y minus 3 gives your encoded number, the original number. But see that when y is 1 or 2 or 3 like that, then the value of this expression, when 1, then it is minus 2, 2, then it is minus 1, when y equal to 3, then it becomes 0, but there is no code for 0, minus 1, and minus 2. See that all the alphabets are coded as 1, 2, 3 up to 26. So 1 to 26, these integers are assigned for the alphabets. So if the code is minus 2, minus 1, or 0, there is no alphabet. So to avoid this confusion or to get the actual alphabet, we modified this expression by adding 26. Okay, what is the value of 26 under modulo 26? No, it is 0. If we divide 26 by 26, remainder is 0. So we can add easily 26, or it is nothing but equivalently 0 under modulo 26 system. So this expression becomes y plus 23. So this is the final expression for decoding or decrypted function. Okay. So this method, in this method, we have used only shift. Only shift is used. Shifting means something is added with another something. So this is called the shifting only. Now, if we use the scaling also, the scaling is also allowed in cheaper. Okay. So if you consider the encrypted function as this way, ex equal to ax plus b. A is the scaling, b is the shifting factor. Okay, A is the scaling factor, b is the shifting factor. But a is not any arbitrary integer. It should satisfy this condition. GCD of a with 26 equal to 1. Meaning, the meaning of this expression is a and 26 are mutually prime or prime to each other. Okay. There is no common factor between a and 26. So we can choose a according to this principle. If a equal to 1, then this formula is nothing but the shift function only. But in this expression, this is the linear transformation. Basically, x plus b is a linear transformation for any arbitrary values of a and b. But here, a has some restriction. It is the prime to 26, and b is a or any integer number. Okay, so if you use this formula, then we can use a shift cheaper. This is also a shift cheaper with scaling. So to illustrate this formula, we consider a equal to 5. Obviously, see that 5 and 26 are mutually prime. No, there is no common factor between 5 and 26. And we assume that b equal to 4. Then what is the expression? Ex equal to 5x plus 4 under modulo 26. So this is the formula. This formula contains scaling as well as shifting. So using this formula or using this encoding formula, the letter A means the value is 1. 1 is converted to when x equal to 1, then this value is 9. 9 means I. I is the 9th alphabet in the English dictionary. So E is coded into I. When x equal to 2, 2 means 10 plus 4 means 14. 14 alphabet is N. And so on. When it is D, D means 26. 26 into 5 plus 4. And it is after modulo 26, it will be 4 only. If we put here x equal to 26, that means 5 into 26 plus 4, and using module 24, that 26, that means if we divide the expression with 26, the remainder will be 4. And what is the code for 4? It is nothing but D. 4 is for the alphabet D. So this is the encoded formula. So using this formula, we can code all the alphabets into another alphabets. Okay. Now the interesting thing is that, so using this code or using this formula, we have converted India, our given message. This India is converted or encoded with WVXWI. Okay. See that I have substituted I equal to 9. I miss 9 in the 9th alphabet. So I have substituted the x equal to 9 after simplification. This becomes 23. The W is the 23rd alphabet in the English dictionary. Similarly, I x equal to n. N means 14. 14 is substitute for x, and after simplification, it becomes 22. 22 means V, and so on. So using this technique, I have converted India into the coded sequence, this one. Okay. But here see that I appears in 2 places, first place and the 4th place. Okay. And the code for I is W, and this code appears in 2 places, first and the 4th place. It is obvious. So the encoding is very simple. No, that there is a straightforward mathematical expression. Using this expression, linear expression, we can calculate or we can find out the coded information. But the question is how we can determine or how we can decode the given expression. So by inverse transformation, if we substitute Ex equal to Y, then x equal to y, then what is the value of x? X equal to y minus 4 by 5. Okay. Now, if y equal to fc, its numerical value is 6. F is the 6th digit. So when I have substituted y equal to 6 in this formula, the expression or the value of x equal to 2 by 5. Okay, 2 by 5 is a real number, not an integer. But all the alphabets as integer, positive integer, 1 to 26. So for if y equal to f or 6, there is no integer number. That means there is no alphabet as per our conversion technique or the coding technique. So question is, what is the alphabet for this real number? There is no alphabet for any real number. All the alphabets are associated with some integers between 1 and 26. So there is no alphabet for this real number 2 by 5. There is no alphabet for this code. Now question is the function acceptable? That means this coded formula is acceptable or suitable, because coding is straight for us, there is no problem, but there is a problem during your conversion. That means for the decoding time, there is a problem. Now answer is yes, this function is acceptable, but we need some more mathematics. That means this inverse formula is not proper. We have to modify this formula by using some mathematical techniques. In J26 means any integer is divided by 26 and its residue as a member of J26 set. J26 is a set of numbers containing 0, 1, 2 up to 25. Okay. So the inverse of 5 is 21. Why 21? In J26, the multiplicative identity is 1. So if you multiply 5 with 21, the value is 105. And under mod 26 is 1, because the 26 into 4 is 104. So mod 26 over 105 is equal to 1. This is the identity element, multiplicative identity element. So the inverse of 5 is 21, or we can say the inverse of 21 equal to 5. So 1 by 5 is here. That means inverse of 5, multiplicative inverse 1 by 25. So we will replace 1 by 5 by 21. Okay. So dy equal to the expression, decoding expression dy equal to 21. 1 by 5 is replaced by 21. Then y minus 4. Okay, it's fine. That means the fractional part is converted to 21. Now this is 21 minus 84. Okay, 21y plus minus 24. Now the minus expression gives nothing. So to convert a positive expression, we add 104. What is the value of 104? It is 0 under modulo 26. Under modulo 26, the value of 104 is 0, because 24 in 26 into 4 equal to 0. So we can add this term without affecting the value of the expression. And after simplification, this becomes 21y plus 20. Okay, 21y plus 20 under modulo 26. So this is the inverse formula or decoding formula for our encoding formula 5x plus 4. That straightforward conversion is this one. See that x equal to 1 by 5 y minus 4 as our conventional mathematics. But this formula does not give any valid alphabets. So we have converted this formula, decoding formula, by this technique using modular arithmetic basically. So this is the Caesar's cheaper using modular arithmetic. Okay. So using modular arithmetic, I have converted the given expression into this form. So I think this is a very nice your expression. No, this expression is acceptable. This expression is acceptable, and everybody can convert or decode the given alphabet. Now encrypted message this WVXWI. That one already I have coded for India. So using this formula, we can decode this expression, and it becomes India. If we verified 1 by 1 character, then we will get India. Okay. So this is the original message. So this is the mathematical treatment of the C-Jot chipper. This is a shifting and scaling formula. This is a very simple formula. It is very simple for the beginners. Now we go for another technique, that one called the block chipper. Okay, block chipper is very systematic technique, and it is more better than our shift chipper. Why it is better? I'm explaining by an example. Now we consider one string of information A, O, X, B, O, P. So we have to convert this expression using block chipper technique. That means we have to encode this this message. So in this case, in block chipper, we consider two alphabets together. Okay, so AO is a block, XB is another block, OP is another block. That means we consider three blocks. Each block contain two alphabets. So all these three blocks can be written as a vectors. See that AO, the first block is written as a vector, AO, column vector. And A is the first alphabet, so its numerical value is 1. O is the 15th alphabet, so its numerical value is 15. That means during the coding, we always use some numerical values for mathematical calculation or mathematical treatment. So A is considered as 1, Y is considered as 15, and so on. X is 24th alphabet, B is second alphabet. So XB is again is the second column, and OP, the last block, is considered as the last column vector. Okay. Now to convert this string of messages, we consider one matrix. This is the matrix, transformation matrix, and this matrix is valid under the mod 26 mathematical operation. Okay. Now using this matrix, we convert the vector AO. A is the transformation matrix. Okay, is an operator here. So we applying this A matrix A to the vector AO. So AO vector means 115. I have written in the previous slide in numerical form. This is the matrix A and this is the column 115. Now we multiplied this matrix with this column. What is the value of first element? See that 1 into 7, 7. 4 into 15 means 60. That means the 67. The first element is 67. And under modulo 26, its value is 15. Okay. And similarly, for the second one, 1 into 1 is 1. 5 into 15 means 75. That means 76. And what is the value under mod 26? That means the 76 is divided by 26. 76 is divided by 26 and residue is 24. So value is 15, 24. Okay. So usual matrix multiplication is applied here, but the final value is written after applying the mod 26 operations. Okay. Now it is, what is the value of alphabet corresponding to 15 is O, and the alphabet for 24 is X. You know that 24 is element is X. Similarly, the second column XB is converted as follows. Okay, XB means 24 and 2. This is the matrix A. This is the column multiplied this matrix and this column matrix, and we obtained 20 and 8 under modulo 26. And alphabet for 20 is T and alphabet for 8 is H. Similarly, we applied the matrix A to the column OP, and after simplification, like previous cases, it's become M and O. Okay. How we clear all this? So what is the coded information? Our original code was AOXBOP, and the converted code is OXTHMQ. That means this one, AOXBOP is converted to OXTHMQ. See the left and rightmost columns. Okay, so this is the conversion technique. But one observation, see that the very interesting observation, O and O. Two O's are there in the second and fifth position in the original string, but encoded string, see the in encoded string, O is converted to X for first time, and the fifth O at the fifth position is converted to M. That means for the same alphabet, same character, there are two different codes. So this is very interesting things. Depends on the position. Depends on the position, the same alphabet converted to two different alphabets. So this is the interesting thing for the block cheaper. Okay, but in the linear cheaper, we have discussed in earlier method, earlier slides. In linear, your linear cheaper or shift cheaper or scaling cheaper, this is not possible. But in block cheaper, the same alphabet is converted to different alphabets. So it is very difficult for the hacker to identify of the original code. So this is the advantage. But so this is the encoding technique. The question is how we will get back. Let me see that the x, if we decode this expression, x should be O and M should be O. Okay. So how it is possible? No, different alphabets, x and M are different alphabets, but we have to convert. We have to convert this string, and x is convert to will convert to O, and this M is convert to O. So how it is possible? See that if we consider the encoding function as this one, EV equal to AV, is the transformation matrix, V is the given vector. So this is our encoding function we have used earlier. Now the decoding, what is the decoding function? It should be the inverse function. No, A and B are multiplied, so multiplicative inverse we will use. So the decoding function, it should be dV equal to A inverse V. For a given V, we will get the decoded vector. Okay, so A inverse, this is multiplicative inverse because A and B are multiplied. So multiplicative inverse is used. So how we calculate the inverse? See that calculation, the method to calculate the inverse of a matrix. So here we have considered the matrix A as 7415 over Z26. Okay. And what is the determinant? What is the method to find out the inverse? Adjoint by determinant. No. So what is the value of the determinant of this matrix? So value of the determinant is 5 into 7, 35 minus 4. 35 minus 4 means 31. So actual value of the determinant is 31, but as it is 5 under modulo 26. Okay, under modulo 26 it is 5. Again, see that the multiplicative inverse of 5 is 21. I have already mentioned in previous slide, the multiplicative inverse of 5 is 21. So the A inverse equal to 1 by 5. Basically 1 by 31. 31 is equivalent to 5. So I have written here 1 by 5. This is the value of the determinant. And this is the adjoint. See, the adjoint contains some negative number. It may contain some negative number. So 1 by 5. 1 by 5 means the multiplicative inverse of 5. And multiplicative inverse of 5 is 21. So 1 by 5 is written as 21. Okay, there is no problem. Now we multiplied all the integers by 21 as a matrix multiplication rules. So first element becomes 105. Minus 4 becomes minus 84, and minus 1 minus 21. 7 becomes 147. Okay. So there is no problem about the positive numbers. Diagonal elements, both are positive. After mod 26, it will reduce to some short integers less than 26 like that. But what we'll do about using the negative numbers? No, in module system, negative number should be absent, should be removed. So what I will do here, see that 105 and 146 diagonal elements remain same, but we added 104 in the second element with minus 84. What is the value of 104? 104 is 0 under modulo 26. Because 4 into 26 equal to 104, so its value is 0. So we can add any 0 with any other number by changing the changing its value. So 104 is basically 0 under module 26. So 104 minus 84 is here. And similarly, we have added 26. So we have added the minimum integer, minimal possible integers, which is 0 under modulo 26 to make the negative numbers as a positive one. Okay. So after simplification using module 26, the number becomes your 125 and 17. Okay. under module 26. So this is the inverse of the matrix. See that this is the original inverse, and this inverse is converted to a integer of matrix of positive integer, and all the integers lies between 1 and 26. Okay. So the encoding vector V is decoded as this one, the inverse V. Now our first encoded vector was 0x. See the first encoded vector is this one, 0x, then th, then mq. This is the coded one. Now we decode these three vectors using this matrix, inverse matrix. So A inverse OX, A inverse OX means 1524 in terms of numerals. So this is the A inverse. And now we multiply these two matrices, matrix A inverse and column vector. And after multiplication and using modulo 26, this expression reduced to 115. And what is the alphabets for 1 and 15? A and O. Similarly, A inverse T is the inverse is applied on the second your second vector, and after simplification it becomes X and B. Okay. Then for the third vector, inverse is applied on M and Q. MQ means 13 and 17. After simplification, it becomes OP. So what is the decoded string? So decoding message is AO. See that AO, XB, and OP. This is the original message. Okay. That means OX is converted to AO, TH is converted to XB, and MQ is converted to OP. So the original message, the decoded message, this is the encoded message. This is the encoded message is converted to AO, XB, and OP. That means this is the original message. So this is the technique for the block cheaper. Okay. So what is the interesting thing or new thing involved here? See that the matrix inverse, we know the matrix inverse in our higher secondary school or undergraduate college, but something is different here. We have used the modulus 26. That one also we know what is the modulo 26 system or modulo system, but we never used appropriately, or we never applied modulo system to solve any particular type of problem. But here we have applied the modulo system to convert the string of messages or string of alphabets like that. Now we make some concluding remarks. Two block cheaper. We have considered two block cheaper. That means two alphabet considered as a block. So two block cheaper can be cracked using a frequency analysis of pair of letters. That means if the hacker knows the encoded process is a two block cheaper technique, then the hacker just repeatedly analyze your code, and after some times he or she can encode or decode the original message. Okay, decode the coded message. That means this is not also the safe one. The idea of two block cheaper easily extend to the blocks of greater length. That means we can extend this concept. That means we can use, say, three block cheaper. That means we can consider three alphabets together. Then what will be the size of the matrix? The matrix will be of size 3 by 3. If we consider four block cheaper, four alphabet consider together, then the size of the matrix will be 4 by 4. And you know the inversion of matrix is a very difficult task. Difficult means contains lot of arithmetic operations. Okay. So if the size of the matrix become large, then you need lot of mathematical calculations. But it becomes more complicated if we consider the larger matrix. Then we need a lot of investigation to hack the coded sequence. But it is possible by the hacker to encode the or decode the original message. Now, one difficulty with the block cheaper is that knowledge of encryption and decryption matrices are essentially equivalent. That means if the encrypted matrix is known, then the hacker can design the decrypted matrices, because the inversion of matrix is very well-known technique. So if the matrix is known, then the hacker easily can decode the original your encrypted information. So this means if encryption matrix is known, one can compute the decryption matrix by computing it inverse. So the encryption matrix must be kept secret for the enemies. Okay, so this is the one drawback. The last paragraph is very important. Read paragraph, see that. Until 1970, the people thought that encryption and decryption using any chipper should be more or less symmetric process. Up to 1970, the people thought that if the encryption method is then its inverse method is the decryption method. But today it is not true. But it is not true in the today's context or after 1970s concept. There are cryptographic algorithms where the encryption process can be made public and decryption is still secret. That means if you just disclose your encryption technique, then nobody can decode it or decrypt. Nobody can decode your uh, encoded messages. If even then your encoding method is public. Okay, the encoding function is given, encoding algorithm or method is given, your string is given. Even then, nobody can decode the messages. So this is the today's development in the cryptography. So this type of encryption is used in ATM transaction, ATM pin, net banking, e-commerce, and many others. Okay. So this is the challenging issues for the hackers. Means the encryption algorithm is known, is open. Even then they cannot design the decryption method or the decoding method. Now I have just introduced you the very basic concept for the coding theory or the cryptography. But for simplicity or for the beginners, but nowadays the people are using the SHA-3. This is a standard algorithm. SHA-3 is a standard algorithm. It is a short name. And in this algorithm, a given message is encoded using 224 bits. 224 bits. For a given string of alphabets, it is converted to 224 bits. You know the SBI banking, they are using 128 bits for decryption or for encryption. Sorry, encryption, their net banking passwords. They are using 128 bits. That means your password is converted to 128 bits. So here we have considered one example. See that the input is 1111, 4 digits. Decimal digits are 4 digits are given, and these 4 digit is converted to this 224 bits. This is basically written in hexadecimal number, not binary. If we convert it this string in binary, it will be 224 bits, 0 and 1. So this information 4 bits pin, 4 digit pins 1111 is converted to this form by the modern algorithm. Modern algorithm means the algorithm are using our today's ATM, net banking, etc. And for the second one, 1112. See that these two numbers 1111 and 1112 both are similar. No, only the last digits are different. Even then, see that the coded information, these two coded information, there is no similarity among the first portion between the converted strings. Okay, so this is the beautiful things of the today's your coding method or cryptography. Digits are same, even then their codes are different. This is the another 1, 2, 3, 4. This is a given input, and this code is this one, hexadecimal code. This is another one. Now you consider another one, the teeny variants of SHA-3, namely SHIC for 8 bits. Earlier was 224 bits, that one very big. But if you consider the 4-bit algorithm, if you use the 4 bits algorithm, then 1111 is converted to this one. This is hexadecimal number. And if we written in binary form, it should be 8 bits. And this is another input 1112. Its code is, see that it is BED. So see that the last digit is changed here also. Only the last digit are different. First 3 digits are same. Even then their codes are completely different. This is another code. This is another code. So these are the example which are converted using the algorithm SHA3. This algorithm contains a lot of mathematical formulas like that. Now these are the references. The first two are the research paper where SH algorithm are investigated. First one is published in 2017, second one 2014, and like that. And last two are the books on the cryptography. The first one is course on number theory and cryptography. It's published in 1994. Second one is also computational number theory and modern cryptography. See that the computational number theory. Ramanujan worked on theoretical number theory, theoretical aspects. But in this book, the computational number theory is studied or investigated. This number theory is used in computational fields or areas and modern cryptography. This book is published in 2012. So these are the books for the beginners. That means those who are interested to work with cryptography, then they can study these two books. Okay. So thank you very much for your patience to listen me. So if you have any question, you may ask.
Participants, you can post your questions in the chat box.
I have one question. They are asking whether cryptography is used only for secret coding, or is there any other applications for that, sir?
Cryptography is mainly used for secure your messages. Okay, so this is the main your objective, and this is done during the long time back. That means the military personals, they are using the cryptography technique in different ways. They are transferring the messages from one place to another place, or from one group of military personnel or one office of military personnel to another office, like that. So mainly mainly these are cryptographic technique is used to secure the information mainly.
Okay, sir.
But it can be used for other areas also. That's coding technique may be used to design other hardware components in computer system. Okay.
Okay, sir. Thank
So,
you, sir.
but I would like to say that the cryptography is studied in two different directions. One is mathematical direction, mathematical treatment, and that can be done by the mathematicians. And another treatment is the computational side. That means we have designed something, some mathematical methods, mathematical formulas we have developed, but the computer peoples, they are applied or they are check whether this method is applicable in the computer devices.
Yes,
That means whether it is applicable to ATM system, or it can be used as a password, like that. Okay. So there are two directions, one direction is mathematical direction. This is on the first development, mathematical development. All these things we have discussed here, all these things are the mathematical development. Okay.
yes,
And the
sir.
computer scientists, they are check whether it is applicable or not. They are
Yes,
check the validity mainly, or how easily we can use this technique for the benefit of the people, or the general people, or the general use sharing.
Thank you, sir.
Thank you, sir, for giving us more information about coding and decoding. Thank you, sir, for your enlightened speech on the topic number and coding. We all are inspired by your great words. Let us continue with the next session. I now invite Dr. Yubarani, Assistant Professor.
Now, thank you. I am leaving because I have another lecture. Okay. Thanks to all of you. And
Thank
if you have any question, then you may send a message. Okay. Thank you.
Thank you, sir.
Thank you so much,
Thank you.
sir, for accepting our invitation. And we are very happy, sir. After a long gap, we are meeting. And the coding and all, it's very, very important topic now in the research field. And I feel very happy that all the participants will be benefited on this topic. Thank you so much, sir.
Thank you very much, sir.
Let us now continue with the next session. I now invite Dr. Yuvarani, Assistant Professor, PG and Research, Department of Mathematics, to introduce our resource person of the second session, Dr. Ravishankar.
Good afternoon to everyone. It gives an immense pleasure to welcome you all for the national webinar on the topic of applications of mathematics. I'm very glad to introduce our resource person, Dr. Ravi Shankar, Assistant Professor, Department of Mathematics, School of Advanced Sciences, VIT University Vellore. Mr. Ravi Shankar completed his schooling at Government Higher Secondary School, Anumandai, Viluppuram. Sir has done his bachelor degree in mathematics at Periyar Arts College, Madras University, and master degree in mathematics and computer applications at Annamalai University, Sidambaram. Dr. Ravishankar has completed his Master of Philosophy at Pondicherry University, Pondicherry, and Doctor in Philosophy at Manonmaniam Sundara University, Tirunelveli. His research topic is a study on zero divisor graph. Dr. Ravishankar worked as an assistant professor and HOD of mathematics in Sharada Gangadharan College, Pondicherry. SAR has undergone 23 training programs in various places and organized 13 conferences and workshops. He has also proceeded 25 international and national conference paper presentations. Dr. Ravishankar has done 43 research works which are all published in good journals. He has also been invited to talk about more research areas in various places, and he also attended 15 conferences and workshops. He is specialized in graph theory, algebra, fuzzy mathematics, discrete mathematics, and applied mathematics. Dr. Ravishankar has published 3 books, namely Latin Square Design and Their Applications, Measures for Selecting Regressors, and Springer book series. He is having 12 plus years more experience in teaching and more as well as in research fields. He is also skilled as an NSS coordinator and also an NCCB certificate holder. Sir, we are very much happy to be with us amongst us today. And I'm also warmly welcome you, sir. I request you to reinforce us on the topic on graph theory, graph from algebraic structures in the second session of this national webinar. Okay, welcome you, sir. Participants, if you have any queries, please give your queries in the chat box. Thank you.
Participants, within 5 minutes, the resource person will join us.
Good afternoon. My voice is audible, ma'am? Sujata, ma'am?
Yes, sir.
Right. Good afternoon. Sorry for the delay. First, I thank to the management, principal, vice principal, head of the department, and the organizing secretary for inviting me to this national webinar on application on mathematics, and for giving me the opportunity to talk about graphs from algebraic structure. Before that, in the school mathematics, Sometimes we are worry about it. Our school mathematics is difficult or easy, or some of the people it will moderate. So some people they are thinking dull, too complicated, too technical, too separate from the each other, from the real life and possible solutions. Some common views on mathematics: so max is so hard, max is so boring, so max has nothing to do with real life. Some mathematicians are mad. Some people school itself we know, and after completing the 10th standard, if you go to +1 +2, if some people say which group you will choosing, means if we say the mathematics group means other discipline people, they are told that yeah, you are great, that's why you are choosing mathematics, like that. But compared to other system, mathematics is very simple. So many people they are thinking once if, the people they will get PhD or postdoc means they are semi mad, but not like that, because many people they are thinking maths has nothing to do with real life. Here, the since technology, engineering, science, and mathematics is a current slogan in the school education in many countries throughout the world. Mathematics and physics are at the core of engineering problem solving and engineering design. It is a challenging but also exciting and highly satisfying career. Many degrees require mathematics, including statistics, physics, engineering, economic, chemistry, medicine, IT, computer game, computer science, social science, psychology, fashion design, business studies, accountancy, electronics, aeronautics, cryptography, and so on. Yeah, just before the one talk, Dr. Madhumangal Pal, say he have the cryptography. So the sending secret message from one person to another person. So many way the ATM pin code. So the ATM person and the system only know that pin code. So these are the main application in the cryptography. Recently, 2 years back in VIT also they offered one course, BTech Computer Science Engineering in specialization of cybercrime, cyber systems, because nowadays we met many lots of problem without our knowing that other people they are took the money from our account, they are misusing our ATM card because of very weak security system. But if you follow the cryptography in particular based on the number system, you can build a strong code. Okay, so without max we would have no TV, mobile phone, internet, credit cards, computer games, CDs, radar, aeroplane, DNA profiling, and so on. Max is energetic working out over hypothesis, payments, and APR calculation, and family budget, etc. Okay. So these are the basic things. So we have n number of the applications. So I already told today my topic is the graph from the algebraic structure. Generally, the many people they know what is graph theory, everything. But every year, not every year, you can think every month, nearly 2,000 to 3,000 paper published in graph theory. So if you go any some particular topic means you will get n number of concept in that graph theory. So that's why I advise to my students. So don't take the graph directly from the particular family. You can take the graph from some algebraic structure. So which subject we need to collect the graph means first we need the number theory and algebra and as well graph theory. So this graph theory concept is based on three subjects. So one is number theory, another one is algebra, another one is graph theory. Okay, right. Sujata ma'am, my PPT is visible for you?
Yes, sir. Yes, sir.
Right, ma'am. Right. Yeah. So before starting, yeah, yes, ma'am.
So I think it can be in the form of slideshow, sir.
1 second, ma'am. Now?
Yes, sir.
Yeah, right. So before starting my lecture, just I recall some basic definition. So for all the audience, even though if you are UG or PG or MPhil or PhD, you can easy to understand this topic, because recently many research going on this topic. Okay, because in graph theory, the domination, coloring, labeling, n number of concepts are available. So you can, these are already well-known concepts, well-known parameters. Many theses published based on these parameters. But at the same times, now if you take a graph from the algebraic structure, you can apply the same topic. It will help for your MPhil and PhD thesis. I already told there is no meaning for MSc, MPhil or PhD student. They can easy to understand this webinar, but it's a very elementary only. Okay. It's very elementary only. So we can start with some basic, because some of the people the basic graph theory, some of the people don't know. So I recall some basic graphs. So look at the graph, it is visible for you. So the graph is collection of vertices and the collection of edges. Okay, so graph is based on two sets. One is vertex sets, another one is the edge sets. So one is vertex sets, another one is the edge sets. So example for the vertex set is S, U, V, W, X, Y, Z. Example for the edge set is you can take the connect between X to S, X to V, that name of that vertices, that labeling name. Okay, right. So what is the edges? So edges, sometimes the people they called edges or link or line. Sometimes the vertex are called by vertex, node, and the point. Okay, so an edge may be labeled by a pair of vertices. For instance, the edge is denoted by E, which is connect between V to W, where E is said to be an incident on V and W. So a vertex is said to be isolated. You look at that, the bottom of the this graph, one isolated vertex means there is no edge incident with that vertex. Then we can say that vertex is isolated. Then parallel edges. So generally, an edge connect between any two vertices. So parallel edges means more than one edges connect between the same pair of vertices. And the loop, an edge starting and ending with the same vertex is called a loop. So this graph is called non-simple graph, or sometimes which is called pseudo graph. Okay, this graph is called non-simple graph, sometimes which is called pseudo graph. So we have n number of application. Let us consider the bypass surgery. Suppose A to B, we have a hole or we have a break in that A to B means we take another one connection between A to B. So bypass surgery. Okay, so many things is available. So generally the non-simple graph, it gives n number of application in our real life. So what is loop? An edge starting and ending with the same point is called the loop. And these are the special graph. It's very simple. The first one is there is no loop, there is no multi-line. So which is called a simple graph. Without loop, without multi-line is called the simple graph. And each edge in a graph have some unique value. Suppose if you think V1 is Vellore, V2 is Chennai, means the Vellore to Chennai, the edge value is 130 kilometers, so 130. So if each edge have some unique values means then the graph is called weighted graph. Okay, then complete graph and complete bipartite graph. So a complete graph means you look at that graph, you can easy to understand. If you choose any two vertices from that graph, there exists an edge connect between the two vertices. Okay, so that is called complete graph. There are five points are available. So the notation for the complete graph is K5. Suppose 6 vertices means that the notation for the complete graph is K6. Similarly, complete bipartite graph. The complete bipartite graph is nothing but the vertex set can be partitioned into two vertex subsets. One is capital V1, another one is capital V2. Then, if an edge exists means one end in capital V1, another end in capital V2. There is no two vertices in V1 or there is no two vertices in V2 adjacent. Okay, it will be denoted by k n comma m, where k n comma n means where n is one side vertices, m is another side vertices. In abroad, if you search in Google, so the complete bipartite graph, you will get the name is marriage theorem. So what is marriage theorem? So total number of people, that is the vertices set, vertex set. So total number of people, they divided in two parts. One is set of all boys, another one is set of all girls, men and women. Okay, so what are the possibility to marriage means? So the one side person, he will choose any one of the girl from the other side. So how many possibility? Similarly, VIVA, if she will choose one person in this side. Okay, so if you free means you can type in Google the marriage theorem. It is the best example for the complete bipartite graph. Okay, then generally a graph is said to be connected. If you choose any two vertices, there exists a path between the two vertices. Okay, so what is connected graph? If you choose a pair of vertices means there exists a path. Either the direct edge connect between the two vertices or there is a path through some other vertices, but it will be connected. Okay, so path is nothing but a path of length n is a sequence of n plus 1 vertices and n consecutive edges. The starting and ending points are different. The cycle is called a closed path. The starting and ending points are same. Okay. Now the one more definition, degree of a vertex. The degree of a vertex V denoted by delta of V is very simple. Look at that graph, you can easy to understand. Even though if you're not studying graph theory also, what is degree? The degree for A is 4, the degree for C is 4, the degree for F is 4, the degree for D is 6, and the degree for B is 3. Look at that. It's very simple. The number of edges incident with a vertex is called the degree of that vertex. So number of edges incident with a vertex is called the degree of a vertex. So previously we start that isolated vertex. So there is no edge incident with a vertex is called the isolated vertex. So of course we can say another definition. The degree of a vertex is 0, then the vertex is called isolated vertex. Okay, so n number of definitions are available, even though it's the same concept also. And each definition we can easy to visualize it. That is the advantage for the graph theory. Okay, you can easy to visualize any definitions. It's not like algebra, homomorphism, automorphism, meromorphism, nanomorphism. We simply say one onto homomorphism, which is isomorphism. But in graph theory, not like that. There are two types of isomorphism. Based on the degree sequence, we can use it. One is inside isomorphism, another one is outside isomorphism. The inside isomorphism, we can take the best example, friends. So their outlook, everything's different, but the behavior is common. That's why we are choosing he or she is my friend, like that. Another one is outside isomorphism. If you consider any twins, the outside look, height, color, weight, everything is same, but if you ask to them what is the which color you like or which food you like, means you will get different answer from the two persons. So there are two types of isomorphism. So totally it is different. The graph theory is very even though the school children also they can easily visualize it. Okay, so any definition, any graph, immediately you can draw on, or immediately you can search from any website, you will get the concept. No need to mug up it, you no need to write like homeomorphism or Galileo's theory. Still now many people we have struggled with Galileo's theory for that unique, I mean, the explanation and everything. But in graph theory is not like that. You can easily visualize it. So this is the first theorem in the graph theory. So already the father of graph theory is Euler. So Euler is the father of graph theory. So it is the first theorem, Euler's theorem. The foreigners, they study this theorem by handshaking theorems. Okay, but generally the Euler theorem means if an edge exists, means based on that edge we will get 2 degrees. One side 1 degree, another side 1 degree. So the number of the total degree of a graph is twice into number of edges. That is called the Euler's theorem. The total degree of the graph is the twice into number of edges. So in general, the sum of degree in a graph is always even, because if odd number of edges also, suppose 5 edges means the total number of degree 2 into 5, 10. If 6 edges means the total number of degree 6 into 2, 12. So the number of edges odd or even. So we will get even number of degrees only. So these are the planar graph. It's very simple. A graph is said to be planar. It can be drawn in the plan without crossing edges. Okay, so then the famous theorem, the Kotowski theorem, it's nothing but a graph is said to be planar. That graph does not contain a subgraph either K5 or K3, 3, because you can't draw K5 without crossing. Similarly, K3, 3 without crossing. So these are the basic definitions. Now I come to the algebraic section. Okay, these points are necessary to recall our graphs from the algebraic structure. The ring theory, already we know, set under the binary operation plus and multiplications, closure, associative, identity, inverse, and commutative. Under the operation plus, and once again closure under multiplication, associative under multiplications. Then one more commutative under multiplications. So the set is called commutative ring. And with the distributive condition, a plus b dot c equal to a dot c plus b dot c. So what is a ring? A ring is a abelian group under addition. A ring is a semi-group under multiplication with a distributive property. Okay, right. So these are the common preliminary property in commutative rings. So generally a ring is said to be commutative, which is satisfying commutative property under multiplication. Already the ring is satisfying commutative property under addition. So we can check the commutative property under multiplication or not, because next we will go to number theory. So generally, in general, in number theory, the A dot B equal to B dot A is true, other than matrices like that. General number theory, basic level, it is true. That's why we can consider that ring is a commutative ring, and remaining some definition. The last one, look at the last one definition, the zero divisor. So what is zero divisor? That is the main point of today my talk. So zero divisor is nothing but we can choose any two element or two numbers in that ring. So the two numbers are non-zero numbers. So A is not equal to 0, B is not equal to 0, but A dot B equal to 0. That is called zero divisor. So how it possible? We know a number is 0, then A into B equal to 0. Either A equal to 0 or B equal to 0 or both A, B equal to 0. So how it possible? Non-zero multiplication, it will give 0. That is possible in commutative ring under multiplications. So these are, I plan to recall these types of graphs. If time permits, we will see all the graphs. Otherwise, we will complete the zero divisor graphs. Right. Now the basic one, Hesse diagram. I start with very simple one, Hesse diagram. So we can represent a partial order graphically using a tool called a Hesse diagram. The idea is to be drawn. Okay, I will, 1 second. I hope that this whiteboard is visible, ma'am.
Yes, sir.
Yeah, right. Now, suppose if I say this graph, this is called a cycle. Is isomorphic with the power set of A, where A is the two element set A comma B. So how it possible? Okay, so the cycle, the name of this graph is called cycle C4. The cycle C4 is the power set of isomorphic with the power set of A, where A is A comma B. Generally, we know the power set means it contains 4 elements. The 2 power 2, it will give 4 elements. So P of A is nothing but the empty, then the singleton set A, B, and the whole set A comma B. So you can easily to draw that the base is empty, and you can consider a set singleton set A, another one singleton set B. Then you can consider the singleton set AB. So now empty is the subset to A, empty is the subset to B, then A is the subset to AB, then B is the subset to AB. So empty also subset to AB, but the equivalence relations, the transitive property, empty is subset to A, the same empty is subset to A comma B. Okay, that's why this one is isomorphic with the power set of A. So in general, the sum of the research paper or some of the MPhil work. MPhil, if you no need to write any new work. So already available work, you can take some specialization graph, then you can apply it. So we can say the cyclic, the coloring of the cycle C4 equal to 2. So what is coloring? To assign same color for non-adjacent vertices or different color for adjacent vertices, like red, yellow, red, yellow. That's why 2 colors enough for coloring the C4. So if you write any MPhil simple work, that time we can take the chromatic number, which is called chromatic number of the power set of A, where A is A comma B is 2, means many people they don't know about it. But if you put the C4, the coloring of the cycle with length 4 is 2, means everyone they know. Those who have the specialized in graph theory, that people they know. Yes, coloring is C4 is 2, in C5 is 3. So even number coloring 2, odd number coloring 3, they know. But if you take the same graph from any algebraic structure, you can write the coloring number of P of A equal to 2 means where A is the singular set A comma B means, I mean the two elements set A comma B means, that people will raise the question, how you say the coloring of the power set is 2? That time you can draw the graph based on the subset logic, then you can assign the color, red, yellow, red, yellow. Okay, and same way you can use domination also. What is domination? To choose the minimum vertices to cover the remaining vertices, that is called domination. The same time you can use the labeling also. So many research approaching is available in graph theory. So domination, coloring, labeling, okay, so decompositions, so you can use it when after getting the graph from the algebraic structure. Now you see the another one more graph. I hope that. What is the name? Cube. Now you can easy to identify it. This cube is isomorphic with power set of A, where A equal to 1, 2, 3, three element set or ABC. You can draw it. You will get how many vertices? 2 power n. The power set number of elements. So 2 power 3, that is 8 elements. So 1, 2, 3, 4, 5, 6, 7, 8 elements. So similarly, you can draw it. Okay. So I saw one thesis, one a master degree thesis in Oxford University. So it's a very, I think, yeah, Oxford University, I think, 80 pages material. So that student, PG students, C or he, I don't know, they try to get nearly 150 AC diagram based on the algebraic structure. These are the simple way. Suppose if you want, sir, I need this graph, for example. Suppose I need this graph from the AC diagram. Okay, so immediately you can think it where A equal to the partial order set. I will consider that set from the partial order set. The partial order set 1, 2, 4, 8. So what is the concept? The A comma division is the concept. So 1, 2, 4, 8. Similarly, you can draw n number of the graph. So 1, 2, 4, 8. So 1 is the divisor of 2. That's why you connect by an edge. 2 is the divisor of 4. That's why there exists a edge connect between 2 and 4. 4 is the divisor of 8. That's why there is an edge connect between 4 and 8. Similarly, you can draw n number of graphs. Okay, right, that's the Hesse diagram. How to get the graph from the Hesse diagram? You can take the subset concept, or you can take the divisor concept, or any way. A number of concepts are available using the partial order sets and lattices also. You can do it. Now we look at that. So here I called the three examples. The first one, second one, third one. Now we look at the first one. So 1, 2, 3, 4. So what is the concept? Less than or equal. The previously the same graph I using the divisor 1, 2, 4, 8. But now the concept is 1, 2, 3, 4. The less than or equal. So 1 is less than or equal to 2. 2 is less than or equal to 3. And 3 is less than or equal to 4. Okay, you see this graph, and just before I show that one graph, both are isomorphic, because that place the concept is divisor, four number of elements in that set. Here also that post set, the partial ordered set contains 4 elements. Okay, so you can draw n number of the graphs which is isomorphic with the same 4 vertices. Generally in graph theory, this one is called tree. And sometimes in general definition, which is called path P4, a path with 4 vertices. Okay, right. Now look at this graph. So what is the concept? The partial order set concept is divisor. So 1, 2, 3, 4. You look at the graph, you can easy to identify it. 1 is the divisor of 2 and 3. You can raise a question, sir, 1 is the divisor of 4, 6, 8, 12 also. Why you not connect between 1 to the remaining element means, which is defined in the partial order set. So based on the equivalence relations, the third one is the transitive. So A is relation to B, then B is relation to C. So A is relation to C. So it seems that 1 is divisor of 2, 2 is divisor of 4, so 1 is divisor of 4. Okay, that's why we not connect between 1 and 4 and the remaining things. And similarly, 2 is divisor of 6 and 4, but 3 is divisor of 6 only. That's why we can add the edge between 3 and 6, not in 4 and 3. So similarly, we can draw n number of concept. So you can easy to write a simple research paper, or you can easy to write a MPhil thesis based on the graph from the partial order set, or the graph from the lattices, or graph from based on Hesse diagram. Which any topic you can easy to choose it. It's a very simple logic. Okay, you can easy to visualize your graphs, and you can after that you can say the coloring of this graph, the domination of this graph. You can talk about anything. Once you will get the graph from your AC diagram or posets or lattices, means after getting the graph, then you will go already available. 50% of the work is already done based on the domination, coloring, labeling, decompositions. So n number of ways are available. Coloring also, it contains 1000 parameters: vertex coloring, edge coloring, magic coloring, anti-magic coloring, and so on. Similarly, domination, edge domination, vertex domination, connected domination, regular domination, irregular domination, and so on. Many dominations are available. Same thing, labeling, graceful labeling, minus labeling, arithmetic labeling, geometric labeling, Pearson labeling. So a number of labelings are available. So from the Hesse graph, from the Hesse diagram also, you can write 100 simple work. Still now many of the works are not started because it's a very simple. So the people, they are thinking for MPhil and a PhD. So if we write any thesis, if no one will understand, means they are thinking our thesis and our concepts are really good. That is not like that. Even though if it is simple work, means we accept, we everybody they are liking it's a new work or not. That is the main point. It's not copy from other books, the plagiarism, other things. That's leave it. If it is simple work, also it is welcome. Don't think about the concept only. The guide and student only know about that concept. Remaining pupils, they don't know about it. Nothing. Okay, so if it's simple work, but it's your new work, your own work, means it's welcome. Okay, so you can consider for MPhil and MSc PG project, you can take these topics: coloring of the graph from the AC diagram, domination of the graph from the AC diagram, and so on. So this is the cube. I already told the power set of three elements set ABC. The concept is subset concept as usual. So the cube is isomorphic with the power set of three elements. The concept of the poset is subset logic. Now, generally, the IC diagram isomorphism. Now you see, we start from poset IC diagram, then we got the graph. Now we jump to the matrices. Okay, from that matrices, you see, for example, this matrix number of rows are 5, number of columns also 5. Okay, so then you can take 5 variable x1, x2, x3, x4, x5. Suppose if you choose 5 variable, then you can make a augmented matrix a into capital X, which is equal to 0, the system of linear equations. So 5 cross 5, you can take 5 variable, then cross multiply it, you will get 5 equations with 5 variable. Then solve the equations. So it will give some answers. The system is, the real number, different answer, real number, same answer, and the imaginary numbers. Because you know the number of solutions of a system is 3 types. Okay, so based on that one, you can jump to the differential equation, or you can jump to Jacobi method or Gauss elimination method, any one of the method to solve the given matrix. Very simple way, we choose the poset, then we jump to graph theory, and based on that graph theory, we draw the matrix. From that matrix, we once again go to algebra. So you see how much connect gives the simple graph from the AC diagram. So how to make this graph matrices means, if you see the graph, any one graph, either left side or right side, left side graph, there is no edge between A to A. That's why A 0 from in that matrix. But there is a connection between A to B, therefore 1. There is connection between A to C, there is 1. There is no connection between A to D and E. That's why we can put it 0, 0. Similarly, to fill this one, you will get the matrix. The matrix is called adjacent matrix. Similarly, there is no unique matrix suggestion. You will get n number of matrices based on these two graphs: incident matrix, path matrix, cycle matrix. Okay, so dominant matrix, color matrix, chromatic matrix. Okay, and chromatic polynomial, eigenvalue of a graph. So if you once you jump to matrix, means you can create a separate theory, that is called algebraic graph theory. You can create a separate theory. Still now many problems are open. You can simply search in Google search engine. So you will get the topics are available or not. If it is not, mean you can write your own way. Even though if it is simple work also, don't bother about other people. You can write, you can discuss with your guide or your teachers, then you can present it. You can take a simple MSc project or MPhil project also. Okay, that is not a matter. Now, next we go to zero divisor. So, 1 second. Yes, right. So, just before I told what is zero divisor. Okay. So, A is not equal to 0 and B is not equal to 0, but A dot B equal to 0. That is called zero divisor. Okay. Generally, in non-mathematician, they know A dot B equal to 0 means there are three possibilities. One is A equal to 0, B is not equal to 0. Another one is A is not equal to 0, B equal to 0. Another one is A equal to 0 and B also equal to 0. But in mathematician only they know if you take two non-zero element, but if you multiply the two element, you will get a zero element is possible. Okay. So now we define a commutative ring. I already recall the definition of a commutative ring. So the R is said to be a commutative ring. We can take the zero divisor of R. Okay, I will consider some example. Z8. Z8. So we know Z8 contains 0, 1, 2, 3, 4, 5, 6, 7. Z8. So I take the zero divisor of Z8. Zero divisor of Z8. So 0 is the one of the zero divisor. Then 2, 4, 6. So only these four members are zero divisor of Z8. So how we know? I will tell. You can see the GCD of 8 and 1 is 1. GCD of 8 and 3 is 1. GCD of 8 and 5 also 1. GCD of 8 and 7 also 1. We know the GCD of two element is 1 means that elements are said to be relatively prime number. So two numbers are said to be relatively prime number. The GCD is 1. If you want to get the zero divisor from the given commutative ring means you can take the non-relatively prime number. So what is non-relatively prime number? The GCD of the two number is not equal to 1, either 2 or more than 2. Okay, so you look at that, the GCD of 2 and 8 is 2, the GCD of 4 and 8 is 4, the GCD of 6 and 8 is 2. So we can take non-relatively prime number, that is the zero divisor. Now, I take another notation, Z star of Z8. So what is Z star of Z8 means non-zero zero divisor. So I avoid that 0. So only 2, 4, 6. So avoid that 0, 2, 4, 6. So only 3 elements. So assign 3 elements. I consider the 3 elements as a vertices 2, 4, 6. 2 into 4, 8. So we know multiplication modulo 8. If it is 8 or more than 8 divided by 8, which one is the remainder? That is the answer. So 2 into 4, 8. 8 divided by 8, what is the remainder? 0. So A is not equal to 0. That is 2 is not equal to 0. 4 is not equal to 0. But 2 multiplication modulo 8 into 4 equal to 0. Because 2 into 4 equal to 8. 8 divided by 8, the remainder is 0. So that is the edge connect between 2 and 4. Then 4 into 6, 24, which is multiples of 8. Therefore, 24 divided by 8, the remainder is 0. There is another edge connect between 4 and 6. But 2 and 6, there is no edge. Because 2 into 6 is what? 2 into 6? Don't tell 12. Because we are mathematician, we know 2 into 6 equal to 4. it is not equal to 0. That's why there is no edge connect between 2 and 6. This graph is called zero divisor graph. Okay, it's very simple. School children also, they can easily to draw the graph. Those they know up to 10th table multiplication, they can easily to solve it. Now take one more thing, Z25. So we know the elements of Z25, 0, 1, 2, up to 24. Then zero divisor of Z25. The zero divisor of Z25 is 0 is one of the element. Then you can check just before I told non-relatively prime number. So what are the non-relatively prime number in 25 element set means 1, 2, 3, 4 not will come because the GCD of 25 with 1, 2, 3, 4 you will get 1. So 25 comma 5 non-relatively prime number 5, 10, 15 and 20. After that I consider the non-zero zero divisor. Why sir you are considered non-zero zero divisor? What about zero means? That is also one of the zero divisor, but nowadays the result is based on the non-zero zero divisor. Many results are going. So non-zero zero divisor 5, 10, 15, 20. So you can consider that 4 member as 4 vertices. So 5, 10, 15 and 20. So 5 into 10, 50, which is multiples of 25. Therefore, there is a edge connect between 5 and 10. 10 into 50, 150. Yeah, once again. 20 into 15, 300. Yeah, 25 is the divisor of 300. So there exists an edge connect between 20 into 15. And the same as 5 into 20 is 100. 25 is the divisor of 100. So 5 into 20. Then 5 into 15, 75. 25 is the divisor of 75. Therefore, there exists an edge connect between 5 to 15. Then 10 into 20, 200. 25 is once again the divisor of the 200. Therefore, there exists an edge connect between 10 to 200. You see, this is a complete graph. Just before we saw the definitions, if you choose any two vertices in a complete graph, both are adjacent. So if you choose any pair of vertices from this graph, the two vertices are adjacent. Therefore, the name of this graph is called K4. So generally we know the complete graph, the coloring of K4 is 4. The coloring of K4 is 4 because red, yellow, we can't give red and yellow because both are adjacent. What is the coloring? To assign same color for non-adjacent vertices or to assign different color for the adjacent vertices. So I assign blue and white. So we need 4 color. If you choose the graph psi of gamma of Z25, psi of gamma of Z25, which is equal to 4 means only few members, those are they know the zero divisor graph, that people only know about it. Okay, the Z25 is isomorphic with K4, therefore the coloring of Z25 is 4. Otherwise, other people, they don't know how that people assign the coloring for Z25. Okay, so Z25, the chromatic number is 4, which is isomorphic with K4. Similarly, you can take Z49, 0 to 48. So now you can directly write non-zero zero divisor of Z49. Non-zero zero divisor of Z49s are 7, 14, 21, 28, 35, 42. No 49 because up to 48 only the members in that graph. So we can take up to 42. So you can assign all the members in the vertices, then assign the name 7, 14, 21, 28, 35 and 42. As usual, multiples of 7 into 42. So 49 is the divisor of 7 into 42. You can cross check it. So you will get the graph, this one. So this graph is once again complete graph. The name of this complete graph is K6. Okay, so how many color enough to coloring this K6? Once again, 6 color enough. Color 1, color 2, because all the vertices are adjacent. So we need 6 colors enough for to coloring this K6. Therefore, the coloring number of the zero divisor graph is at 49 equal to 6. How many people they know, even though the graph theory people also available, suppose if they know zero divisor graph means, yes, they can easy to visualize it. Otherwise, they don't know zero divisor graph, but they are in their specification is graph theory means that people how they will verify it, they don't know. Once if you know the algebraic structure of the ring theory, either a commutative ring or the normal ring structure, because we only consider the number system only. So normal ring also enough to construct the zero divisor graph. Then the zero divisor graph exists for all the ring means no. Suppose if you consider the integral domain, you know, many people you know. So what is the integral domain? A commutative ring without zero divisor is called the integral domain. Without zero divisor is called the integral domain. Let us take Z11. So Z11 contains 0 to 10. Find the zero divisor of Z11. Non-zero zero divisor of the Z11 is nothing, empty, because all the elements between 0 to 10, the non-relatively prime number with 11. So 11, comma, any element from the Z11, you will get GCD is 1, because 11 is a prime number. So the Zn, where n is a prime number, then we can't find the zero divisor. So that type of commutative ring does not contain the zero divisor graph. Therefore, the zero divisor graph is not unique, or it will be exist for all the commutative ring means no. So it will exist only non-integral domain. Okay, if it is integral domain, the zero divisor graph does not exist. You can write the reason, because all the elements in that Zn, where n is the odd number, n is the prime number, which is non-relatively prime number with that n. That's why there is no zero divisor. Once if you can't find the zero divisor means you can't draw the zero divisor graph. Right now, Z15. So 0 to 14. So Z15 is 0 to 14. So non-zero zero divisor of Z15. 3, 5, 6, 9, 10, 12. Yes. 3, 6, 9, 10, 12. Now assign the vertices 5, 10, 3, 6, 9, 12. Okay, 3 into 5, 15. 15 is the divisor of 15, therefore remainder is 0. So 3 and 5 are 0 divisor. Then 5 into 6, 30. So multiples of 15. So there exists a 5 into 9, 45. Multiples of 15. 5 into 12, 60. Multiples of 15. Then 10 into 3, 30. So multiples of 15. Similarly, 10 into 6, 60. Multiples of 15. Then 10 into 9, 60. Multiples of 15. Then 10 into 12, 120, which is also multiples of 15. Therefore, this one. There is no age between 5 to 10, because 5 into 10 is 50. 15 is not a divisor of 50. Similarly, 3 into 6, 18. So 15 is not a divisor of 18. That's why there is no age between 3 to 6. So it's a very familiar graph, which is called complete bipartite graph, because the vertex set is decomposed into two parts. One is capital V1, another one is capital V2. If an edges exist, mean one end in V1, another end in V2. The name of this graph is called K2, 4, the complete bipartite graph, or sometimes which is called K4, 2, both are same. If you mention K2, 4 or K4, 2, both are same. Okay, so you can take n number of the graph Z15. How I find out that graph is complete bipartite graph means 15 can be written as 3 into 5. Okay, so what about 3? 3 is a prime number, 5 also prime number. So if any number n, which is multiples of different prime numbers, different two prime numbers, you will get a complete bipartite graph. You will get a prime factorization. That is the number theory logic. We can use the prime factorization. Just before we know the graph, gamma of Z15, the notation is gamma, the zero divisor, is isomorphic with K2, 4. It can be rewritten as gamma of Z3 into 5, which is isomorphic with K3 minus 1, 4 minus 1. Yes or no? We can write 3 minus 1 and 4 minus 1. So we will get, sorry, not 4 minus 1, 5 minus 1. 5 minus 1. Okay, same thing if you draw the graph Z, Z 3 into 7. That is gamma of Z 21. So you can identify what is the graph means K 2 comma 6. So gamma Z 21 is K 2 comma 6. So in general, if you can take the complete bipartite graph logic, gamma of Z P comma Q, PQ, where P and Q are distinct prime number, then which is isomorphic with K P minus 1 comma Q minus 1. Okay, also the just before we saw one graph, gamma Z25 is K4, which is nothing but gamma of Z5 square, which is equal to K5 minus 1. Then another one more complete graph, gamma of Z49, which is equal to K6, which is equal to gamma of Z7 square, which is equal to K7 minus 1. So if you want another one more complete graph means which graph you will get, you never get K5 in zero divisor graph. You never get K7 in the zero divisor graph. Okay, so after that you will get which graph means what is the next prime number 5, 7. The next prime number is 11. So gamma of Z121, which is equal to K10, which is equal to gamma of Z11 square, that is K11 minus 1. So what is the next graph? Next prime number 13, so K12. So you will get a good point from this graph. If you get any complete graph from the zero divisor graph, the number of vertices in that graph is even. You never get odd number K4, K6, K10, K12. Okay, then you can take a simple work, some project work or MPhil thesis work, the Eulerian and Hamiltonian in the zero divisor graph, or the Eulerian and Hamiltonian in the graph from the algebraic structure, or Eulerian and Hamiltonian graph from the commutative ring. So you can write a simple MPhil work or simple MSc project from this concept also. Okay, so this I explain only two family. Okay, nearly we know 100 families are available, but it's not unique. Every day we can generate one by one. So if you choose a graph gamma Z10, so the zero divisors are the elements from 0 to 9. The zero divisors are 2, 4, 5, 6, 8. The non-relatively prime number to 10 to this number. So assign the vertices 5, 2, 4, 6, 8. I know 2 into 5, 10. 4 into 5, 20. 5 into 8, 40. 5 into 6, 60. See, I will get a star graph. Okay, so have you another name of this graph is K1 comma 4. The another name of this graph is K1 comma 4 because the gamma of Z10 can be rewritten as gamma of Z2 into 5. So 2 into 5. So it's a complete bipartite logic. So if you draw another graph gamma of Z14, it can be written as gamma of Z2 into 7. So what you will get the graph which is isomorphic to K1 comma 6, a star graph. So we can easy to draw the star graph, then the complete graph, then the complete bipartite graph. Okay, similarly n number of you can take 2p where p is a prime number, 3p where p is a prime number, 4p, 5p, 6p, and even number 4p, 6p, 8p. So we will get nearly infinity number of families are available in zero division. We can't collect all the zero division graph, then we can put in some particular family means that is impossible. So we will get n number of families are available. Yes. So this Tibet, he was introduced this concept in 1988, a recent work only. So still now only n number of papers are published in zero divisor graph. Many open problems and open works are available. So I bet he introduced the zero divisor graph, but in particular he is very much interested in coloring. So based on coloring only he will introduce you look at that graph. Just before I draw some graphs based on the zero division, what is the difference between that graph to this one means this graph, the IBEC consider zero is the one of the zero division. That's why zero is inside a member, inside a vertex in that graph. So as usual, zero is connected with all the vertices. Okay, zero is connected with all the vertices, and remaining things 2 into 3, which is multiples of 6, that's edge connect between 2 and 3. Similarly, 3 and 4, 12. So therefore, there is exists edge connect between 3 and 4. But 0 is multiply with any element, you will get 0. That's why we can add the edge between 0 to the all the remaining elements. Okay, so it is another one. You get 12. So 12 elements. So if you remove 0, this vertex means you will get the zero divisor graph. That is called the Anderson-Livingston graph. So now the many research based on the Anderson-Livingston graph only. So his paper, the origin of this research paper is published in 1999. So now this paper contains nearly 2000 citations. I know, but I don't know because every day they wrote 1 or 2 paper based on the Anderson Livingston. So myself and my students also published nearly 40 papers based on the Anderson and Livingston paper. Okay, so what he considered, his paper is based on IBEC only, but he avoid the zero is the one of the zero division. He considered only non-zero zero division. That's why he avoided zero. So he only get this graph 2, 3, 4 only. So which is called Anderson-Livingston zero divisor graph. In general, now your research is based on Anderson-Livingston. So if you mention simply zero divisor means that people they understood, okay, that graph is based on Anderson and Livingston. Okay, but both will give the different answer. You see, this graph is totally different, this graph is totally different. So you can write a thesis, the coloring of IBEC zero divisor graph, or the domination number of IBEC zero divisor graph, or the decomposition of IBEC zero divisor graph, or the labeling of IBEC zero divisor graph. Okay, you will get some different result compared to the Anderson Livingston. Both are different graphs. So you will get different types of solutions and different types of images, and coloring numbers also different. Okay, right. You look at that, this is Z12 for the Anderson because we avoid that zero. But in IBEC, he considered zero is also one of the zero divisor. That's why he connect zero with all the element in that Z12. So this graph and the Anderson Z12 both are different. Okay, so you will get a different result. At a time, 3 students you can start to write the thesis based on domination, coloring, labeling, and decomposition, IBEX, same as Anderson, Livingston, and Mulai's zero divisor graph also. So this is the Mulai zero divisor graph. What he did it means he collect all the equivalence classes. So 2 is one of the equivalent classes, and 4 is the another equivalent classes, and 6 is the another equivalent classes, and 3 is the another equivalent classes. Okay. So if you know the equivalent classes in the graph, algebraic structure, so you can combine all the elements in some particular equivalent classes, then you can connect it. So 2 connect to 6 and 4, 3 based on the equivalent classes, which is called the Mulai zero division graph. So this is already we know the zero divisor graph of Z6. So we will get this one. So we are consider only non-zero zero divisor. So based on the simple work handwritten, we collect many graphs, but we got some points based on the manual graph drawing. What is that means? Our initial approach to this task was to draw as many graphs as we would be hand. After many tedious drawing, we realized that once you got into large number, because if n equal to 100, we can draw it. But n equal to 1000 or 10,000 means we can't plot the points for the 1000 vertices. So that time it is necessary, we will get the help from the software. Okay, so LaTeX is available, Mathematica is available, our software is available. Okay, but here the Mathematica is really nice. It will support to draw the zero divisor graph. So mathematical computer program became our best friend. Otherwise, you can't get the larger number. Gamma Z 2250 means we can't get that graph. Also, we can't image also that graph. Okay, so that time the mathematical software it will be helping. So we use the mathematical software Mathematica. So we draw this graph, the Z33. So Z33 is a complete bipartite graph because 33 is decomposed by 2 different prime number, 3 into 11. So what is the name of this graph? K 2, 10. which is isomorphic with k 2, 10. And similarly, gamma of z 25. So gamma of z 27. So these are very simple graphs, so we can easy to draw in by hand. Okay, these are very simple. Gamma of z 18. It's a case of p square q, where p is a prime number, q is also the prime number, p square q. So you can take the combination, the number system combination, p square q, p cube q, p power 4 q, n numbers, and p square q square, p square q cube, and p square q square r square. P q are multiples of prime numbers. So the number of families not unique in zero divisor graph. So the result based on zero divisor graph is, we can't stop that result. If you go one generation, next generation also we can take some PhD or MPhil thesis based on zero divisor graph. No one will tell, I find out all the families of zero divisor graph, because it contains infinite number of families. We can't put all the zero divisor graph into some particular families. That is impossible. So next generation also, if you want to do PhD in mathematics, means we can take the concept from this zero divisor graph. Okay, see Z30. These are very simple number, very less number, so we can easy to draw in hand. Suppose if you go the larger number, you see Z60 and Z36, Z72, Z96 also is possible. We can draw it. See Z6561. So it's really difficult to visualize that graph, but we can draw that graph with the help of mathematical software, and some other softwares are available. So we prepared for Mathematica and LaTeX, we can draw that graph. Okay, right. So based on our study of over 100 zero divisor graphs, we were able to conclude that the complexity of the graph is dependent on the complexity of the prime factorization of the number we are doing modular arithmetic with. Okay, so this the zero divisor graph is over. Then we can take the identity graph. I think time permit, I will continue with this topic. Otherwise, just you look at that. Okay, so let z2 equal to 0, 1. So which is identity graph with the under addition modulo 2 means. So 1 is always connected with the identity element 0. Okay, if you see 1, 2, 3, okay, you can consider this one. So 0 is the identity element, so which is connected with all the elements 1, 2, 3. But 1 plus 3 is 4, which is multiples of 4, therefore 1, 3 connected by an edge. But 2 connected with 1 and 3, it will not give the multiples of 4, therefore 2 is not connected with 1 and 3. So based on this concept, if you draw the graph, which is called the identity graph, you see the Z4 zero divisor graph also available, but Z4 the identity graph also available, but both are different. So in Z4, Z5 for the identity graph, what we will get means all the element it be a vertices. We can consider that element as a vertices. But the only 0 is connected with the all the element. So it will little coincide with I-beg zero divisor graph, but both are different. Because here addition modulo 4, but I-beg zero divisor graph is based on the zero divisor logic. Similarly, the cyclic group, okay, the multiples based on the multiples, because G6 equal to 1. What is the given condition? For example, like the cube root 1 omega square. Okay, omega cube equal to 1. Similarly, here G6 equal to 1. So based on that one, you can draw the graph. Okay, G into G5, G6, that is 1. Therefore, there exists edge connect between G to G5. Similarly, G square to G4, multiplication, we will get G6. Therefore, there exists edge connect between G square and G4. So similarly, you can draw the n number of graphs. Okay. Now, so the final, so we completed the topic. So I think the original time is allotted to me is 4 to 5, but already sir continued with 2 o'clock. So we can, it's live streaming also. So Sudha ma'am requested to me, because I have class at 3 to 4, because so now online classes are going. So I might cancel my class and come back. That's why I took 5 minutes late. So if you have any doubt, you can raise or you can post. I will answer to you. So if in future, if you have any doubts or any research-oriented work, means you can contact by my mail. If time permit, I will help you. Once again, I thank to Sujata ma'am for giving this wonderful opportunity. Thank you.
So there is a question from the participants.
Yeah.
Sir, what is a zero divisor in a ring?
That's why it is a well-known definition in commutative ring, the ring theory. So A and B are not equal to 0, then multiplication of the two element equal to 0. So you can read the ring theory logic, you can easy to identify it.
One more question, sir. A's diagram and graph theory, what is the difference between these two, sir? It's a question.
A's diagram and graph theory. See, all the diagram is graph theory. So if you draw any graph, must be a graph theory logic only. So we can compare the graph from a AC diagram, because AC diagram is a support for the set theory, like partial order set or pore set. So how we will get the graph from the pore sets? That point only we consider here. Both are same. AC diagram is one of the graph. Okay, we will get the graph from the AC diagram, but conversely we can't go for the pore sets. Right.
Thank you, sir.
Thank you, ma'am. You are running, ma'am.
Yes, sir.
Yeah.
Any other questions?
That's all, ma'am.
Participants, you can post your questions in the chat box.
Questions, Priyanka, you can continue.
Yes, thank you, sir. The session was very informative. You have combined both graph theory and algebraic concepts and have explained in a very clear manner. We thank you very much for your time, sir. And you also given very open, many open problems, and you have inspired the participants. Thank you very much for that, sir. Thank you.
Thank you, ma'am.
Feedback link will be posted in the chat box. Participants, kindly fill the form. Feeling a gratitude and not expressing it is like unwrapping a present and not giving it. To express the gratitude, I now invite Ms. Sangeeta, student of 1st MSc Mathematics, to propose the vote of thanks. Vote of thanks is followed by the math anthem.
Good evening to one and all present here. On behalf of PG and Research Department of Mathematics, I consider it as a proud privilege and honor to propose the vote of thanks on this special occasion. The hardest arithmetic to master is that which enables us to count our blessing, says Eric Offer. First and foremost, I thank Almighty God, for the Lord is good and his love is boundless. Henry Ward Beecher calls gratitude as the fairest blossom which springs from the soul. My thanks to our resource persons, Dr. Madhumangal Pal, Professor, Department of Applied Mathematics, Vidyasagar University, Midnapore, West Bengal, and Dr. J.RaviSahankar, Assistant Professor, Department of Mathematics, School of Advanced Sciences, VIT University Vellore, for accepting our invitation and honoring us with your gracious presence and delivering inspiring lectures amidst your busy schedules. Sir, we all inspired by your valuable talk. I express my hearty thanks to Reverend Sister Alice Katie, Secretary, Dr. Sister Jaishanti, Principal, Dr. Sister Amla Valarmadi, and Sister Sumati, Vice Principal, Shift 2 and Shift 1, for your enormous support and guidance during the organization of National Webinar. I thank Mr. Dinesh, Catalyst and Executive Director, Audacious, for your full support throughout the program. I extend my thanks to all the faculty members, research scholars, and students from different parts of India for your wholehearted participation. Once again, I thank one and all. Thank you.
Thank you, Ravishankar sir. So we have preponed your talk because we have fixed your talk from 4 to 5, but we have preponed your talk. Thank you, sir, for accepting our invitation. And the talk was really excellent. And you have given, as Priyanka said, you have given the open problems is also there. The students will be much benefited.
Yeah.
Thank you so much, sir.
Can I?
God
Participants, kindly fill the feedback form. Within 10 days, you will receive your certificate.
So thank you so much, everyone. The participants, the attendance form, which is available in the live chat box and also in the comment box. If you missed the form in the chat box, please fill the form in the comment box. So thank you so much, and we're officially ending the session, live session now.
Thank you, Dinesh sir.
Yeah.
Without your support, I think very difficult for us to manage strength of the participants also, I think so. Thank you for giving us the technical support.